This presentation will discuss the impact of radiant heat on the flexural strength and impact strength in spruce wood bending. The authors of the paper and this presentation are Anton Osvald, who is the corresponding author, and Jaroslava Štefková. The research presented in the paper describes the experiment, which consisted of several steps. First, the material chosen was Norway spruce as the most common wood species in Slovakia and also economically most significant. Secondly, we proposed the laboratory testing method and laboratory testing instrument. The important step was to choose the evaluation criteria and to conduct the evaluation itself. Now let's discuss samples and laboratory testing device. As I have said, the material of samples was Norway spruce. Then it was cut into samples of these dimensions, 350 times 200 times 20 millimeters. The moisture content of the samples was 10 plus minus 1%, and the density of the samples was 385 plus minus 10 kilograms per cubic meter. Now let's talk about the testing device. The testing construction consisted of three main items. The first one was the frame, in which one of two radiant heat sources, either with one tube of 1000 watt output or two tubes of 1000 watt output, which creates the overall output of two sources of 2000 watts. Then another part was a sliding adjustable holder of a test sample, which enabled to hold the test sample in 50 millimeters, 100 millimeters, or 150 millimeters distance from the source of the heat. Let's briefly describe the experiment procedure. There were three characteristics measured: mass loss, flexural strength, which is measured as modulus of rupture, and impact strength in bending. Here you can see the number of samples used to measure the characteristics. The individual samples were then exposed for 2, 5, 10, 15, and 20 minutes to the heat source of 1000 watts and 2000 watts at every defined distance, which means 50 millimeters, 100 millimeters, and 150 millimeters from the heat source. All results were recorded. Now let's look at the evaluation criteria. The mass loss was the first characteristics measured because if there was no mass loss at bigger distance and/or shorter time of exposure, the samples were excluded from further evaluation as there was no influence of thermal loading recorded. The equation you can see on the left side was used to calculate the mass loss. The table provides information on behavior of the samples in this experiment. On the right side of the table, you can see different colors for different time of exposure to the heat source. On the left side, or individual bars give information on the percentage of the mass loss. The next evaluation criterion was modulus of rupture, by which flexural strength is measured. Modulus of rupture was one of the most important evaluation criteria. The essence of the test is to investigate maximal loading before the test sample breaks. The loading force is applied in the point of the greatest damaging of the test sample, but on the reverse side from the exposure. The modulus of rupture in bending was calculated according to the equation you can see on the left side of the graph. The graph gives the information on behavior of samples in different distances and also in different time of exposure. The last evaluation criterion was impact strength in bending. Impact strength in bending tries to find the toughness of the samples in a section bending and the dynamic loading. The testing device is an impact pendulum. The energy used to break the test specimens is measured with 0.01 joule precision. It is calculated according to the equation you can see on the left side of the graph. The graph shows the behavior of samples in different distances and in different time of exposure to the heat source. The following 3 slides show the comparison of 2 heat sources. 1000 watt source is illustrated in blue color and 2000 watt source is illustrated in red color. This slide shows the comparison of sources regarding the mass loss. We can see that the mass loss increases sharply after the 10th minute. This slide shows flexural strength of the samples exposed to 2 heat sources. The flexural strength of samples exposed to 1000 watt heat source decreases very slightly, while the behavior of samples or flexural strength of the samples exposed to 2000 watt heat source decreases more sharply, with small or 5-minute stagnation between the 5th and 10th minute. This slide shows the comparison of the values of impact strength of samples when they are exposed to 2 different heat sources. When we look at the graph shows that the behavior of samples exposed to 2000 watts goes steadily down from the 2nd until the 20th minute. When we look at the blue line, which shows the behavior of samples exposed to 1000 watt heat source, we can see quite unexpected increase in impact strength in the 5th minute. After this time, it goes down or it decreases steadily until the 20th minute. I'm approaching the end of the presentation in which I have described the testing method and the device, the 3 evaluation criteria and the results of the individual tests. The results of this experiment expand the knowledge on behavior of spruce wood. We can also see that the changes caused by radiant heat are significant in all 3 measured criteria. For further research, we would suggest to conduct more experiments with other wood species, including tropical wood species, and also various retardation treatments, including thermally treated wood. Another criterion that we would add to the previous criteria is the measuring of the char layer depth. This slide presents the sources which were used to create this presentation. Even more sources. Thank you very much for your attention. Please leave some comments or questions in the provided space.